Every mine planning engineer looks for the tool that truly fits their needs. In this video, we'll show planning approaches in the K-Mine scheduling module. There are 3 approaches, grouped into automatic and manual. Within the manual group, we'll demonstrate 2 methods. To begin, create a project in scheduling. Add a block model, mark the areas, define how you'll mine them, and decide on your tasks and expected outputs. If you're building a long-term or medium-term plan, the automatic solver is ideal. Set your target indicators and let the tool determine when, how much, and what to extract to meet those targets. Targets can be defined by groups, and you can prioritize extraction by manually intervening in the automatic process. The calculation results are presented as sets of blocks by planning periods. After each interval, review the remaining ore/rock tonnage in each area and adjust extraction priorities for the next period if needed. Any interval, or all intervals together, can be shown as charts and diagrams based on the figures in the result tables. Charts make planning outcomes easier to read. Results can also be exported as solids and polylines by planning period. That covers the first approach. It's great for long and medium-term planning and uses target indicators. Now let's look at a more manual, more detailed approach. The next approach is applicable across planning timeframes and can be used in all cases. Here, we decide when and how much must be mined from each area to meet our targets. We use extraction units. Here, they're abstract, representing mining intensity per area, and we adjust that intensity manually using events. In practice, you set the required productivity rates for each area in a given time period and use that for planning. For analysis, view the charts. If ore is insufficient, increase intensity on available areas. If stripping is the constraint, open a new prospective area, and so on. For a broader picture of planning results, you can add transport routes. If you include haulage, configure all receiving points and their requirements. Reporting becomes much more detailed. You can review results as tables, enough to convey the full picture of deposit extraction by planning periods, by excavators, by areas, each broken down by levels and aligned to intervals. Transport reports also include expanded statistics split by loading points, unloading points, rock types, and route types. At the end of the transport section, there's a summary report for the period including haulage metrics. Each calculation period has its own unique set of blocks that reflects operating conditions and can be displayed separately. You can also export these results as solids and polylines. The next approach is even more detailed and suits short-term planning best, although it can be used for medium-term in certain cases. Here, we place real excavators, the actual fleet with their productivity across the pit, and specify all locations where each unit can work. Using excavator events, you set the sequence of equipment movement across areas. As before, you can include the transport network to obtain more detailed planning results. You'll see the mining sequence differs from the previous variant because area intensities were changed. Don't forget to open the tabs with pre-configured charts. They present the planning concept more clearly than tables and make comparisons easier. You can also export to Excel for deeper analysis. A chart clearly shows whether target indicators were met. If not, adjust equipment operation and track the outcome. This way, you can build a plan for deposit extraction for both long-term goals and short-term needs. The 3 options shown are not exhaustive. Everything is in the hands of skilled engineers.